All right, in this last part of the lesson, we're going to talk about the firewall in Linux. So Linux has always fundamentally been a firewall. It's had a router, firewall kind of baked into the kernel since the very beginning. But basically, a firewall's job is to decide what messages or packets should be permitted or denied on a network, right? And fundamentally, that's basically what a router and/or firewall does. By the way, the line between a firewall and a router used to be pretty blurry, right? Because routers and firewalls kind of did similar things. But today, mostly you'll find routers making decisions about where to route traffic, and firewalls are more focused on the data coming in and out of a network and trying to detect any attacks and things like that, while also providing high availability, right? And I'll talk a little about how that works. But the tools that we have in a firewall, the things that we can look at, think back to the IP packet header, the TCP segment header, and even the frame header from these different layers of the TCP/IP model. We had things like addresses, like source and destination MAC address, IP address, or port numbers. We had the protocols and so forth, right? So there was some information in those headers that we can use to make decisions about what to do with this data. And also, you'll hear this term stateful firewall or stateless firewall rules. A stateful firewall means that it not only can make decisions based on what's in the header in those packets, but it's smart enough to be able to track those headers to know, or, in segments really, this is really when we're talking about segments, to track those headers and have a memory to know how they're in context with each other, right? So it knows that a segment is in context with an already open and established connection. Think about this. This is important when somebody, normally you would want to block traffic coming into a network from the public internet. But if I'm behind that firewall, if I'm inside the network and I want to get information from a web server, you need to allow that traffic back because I requested that information. I want it back. So a firewall has to be smart enough to know that this packet coming in is in context with a request that came out. And TCP has that mechanism in the segment header, right? It has all the acknowledgement and sequence numbers, so it can keep track of all that, right? So there's some intelligence. It's called net filter. It's baked into the kernel, net filter. It's a fundamental part of Linux, as I said before. But the only way we can interact with that is through IP tables. And I've talked about IP tables just a little bit before. If you recall, in the first lesson in this module, I talked about how IP tables works, right? I talked about the different IP chains. So really, net filter is the mechanism in the kernel that does that. IP tables is how we manage it. I didn't show you any examples in that PowerPoint. There is one in the PDF. If you download it, I show some basic examples. But if you look on the bottom of this slide, those are some real-world examples of what it looks like to write these rules for IP tables. They can get pretty convoluted and complicated. They're very powerful, but they can be very complicated. So there are two firewalls available for Linux using that layer on top of IP tables. So rather than us having to type in these IP tables commands ourselves, there's a layer on top of that can manage that for us, that gives us a much easier mechanism to manage our firewall rules that makes more sense to a human, right, than these series of complicated rules and IP tables, all these chains that we can work with. The first of the two is Firewall D, which is mostly on Red Hat-based systems. So Red Hat-based systems usually use Firewall D. Firewall D has two ways that we can work with it. There's a GUI-based tool, and then there's a command line tool. Like most things in Linux, the command line tool is a lot more powerful. You can do a lot more with that command line tool. The GUI tool has a little less flexibility, but it's also a little less intimidating to use it, right? There are two versions of Firewall D that are always running. There is the current runtime version, and then there is the permanent version. So the current runtime version, you can modify that current runtime version, but it won't affect the permanent version. So the next time you bring the service down and bring it back up or restart the system, it's going to go back to that permanent version. So when you're working with these firewall rules, you might test them. You say, okay, I want to roll this into the permanent version, so the next time it restarts, that rule will be in place, and it affects the system going forward. So it's important to keep that in mind when you're managing these rules. So here are just some of the options that are available with Firewall D in the Firewall D command. And again, more of the configuration options available. This is described in more detail in the textbook. And we'll also be working with this command in the lab environment, because we're using CentOS in this course. In the lab environment, it has Firewall D, so you can play around with it and see how to create rules and work with zones. These are also some of the options that you have when you're working with the command. Again, these are described in more detail in the textbook, and you'll see this when you do the hands-on exercises. And one more slide showing these options with the command. And another slide. All right, so here's an example of someone running some of these commands with Firewall D, right? So you see in the first example, somebody's using the Firewall CMD command to get a list of all the current active zones, right? Or zones that we have available. So those are all the zones that are set up by default, right, in the firewall. When you get default zone, which is that second command, it's showing us which zone is the default. So by default, it's public. So whatever rules are set up in public, those are what's active, right? You can only have one zone active and bound to an interface at a time. If you have multiple interfaces, you can have different zones on different interfaces. So you can have a private interface and a public interface, for example. Most servers only have the one interface, right? So you'll have one zone that's active on that one interface. The next one is adding HTTP to a zone. So it's making HTTP, making it available, right, as a service on that system. So somebody could communicate to HTTPD on port 80 and 443, for example, right? HTTP is going to be on 80. You add the S on the end, and that'll also enable 443 HTTPS. So if you look down a couple more, we have, let's see, set target default for HTTP, right? So this is really just kind of adding HTTP and HTTPS as services available in the current public zone, so that people can communicate with our service or our server on those ports. So pretty basic, right, that it's setting up these ports. We do this in the lab, right? We're going to set it up so that we can use certain ports. We have to do this in most labs anyway if we're going to be able to communicate with some service that we install on the server that runs on a port. So some of you have probably already done some of these commands. And again, these are just some additional examples for you from the textbook. Now in Debian, instead of using Firewall CMD or the Firewall D daemon, instead it uses UFW, which is short for Uncomplicated Firewall. So this is going to be in Debian distros. In theory, you could still run Firewall D on Debian. You can, and other way around, right? There's packages available for both. So it's possible to run either on either of these. I will say UFW, it's definitely a little bit simpler to set up, less complicated than Firewall D. However, with that less complication comes less configurability, right? I would hesitate to say that one is better or worse than the other, right? They're both pretty good firewalls, right? They're pretty good in their own right, probably better than a lot of alternatives. But having that flexibility is nice in Firewall D, but that also means it's a little bit intimidating. Having that simplicity in UFW is nice, but when you need some granular configuration, with flexible configurations, then sometimes you're going to wish you had Firewall D. But again, both are pretty good. Both are useful. I will say that and I mentioned this in lesson 1, that Linux makes a great firewall. And in fact, many appliances that you buy as a firewall appliance, for example, F5 and SonicWall and things like that, a lot of them are really running Linux under the hood. Even Cisco is running some variation of Unix under the hood, probably BSD. No one really knows for sure, right, over the years. But all of these Unix or Nix-based systems are really good at being a firewall. And really, the only difference between a Unix or Linux server and something like a firewall appliance is that they just have custom software and better hardware to be a firewall, right? So it's optimized for that job. But fundamentally, they're really very similar, if not the same.